I come from the Stone Age. We don't have PowerPoints in Wales. I'm afraid we're back on overhead jellies, so you'll have to abide with me. My particular interest from the GP perspective is in getting people well. And in order to do that, we have to actually identify what is going wrong at the cellular level, identify those errors, and by correcting those errors, we can get people well, basically. And so the question I've been asking myself for the last 25 years is, what is it that's going wrong that makes these people so fatigued? And my practice has been revolutionised in the last 2 years because I think that together with a brilliant biochemist, John McLaren Howard, we have really nailed the central pathological lesion that's going on in people with fatigue syndromes. And my ideas came from 2 papers. This was a paper that was commissioned by the National Institutes of Health in America when they asked Peckerman to try to find an objective test of fatigue. This was for the benefits of insurance payments and the like. I.e., how do they know whether patients were malingering or whether they had something genuinely wrong? And he's a cardiologist, and he looked at the clinical symptoms and signs of these patients, and he said, well, basically, they're in heart failure. These patients are suffering from low-output cardiac heart failure. And he went on to prove that in this paper, which measures cardiac output in patients with fatigue syndromes, and finds that the sickest patients have the lowest cardiac output. And then that begs the question, well, why? The next clue came from a book that I read by another American cardiologist called Stephen Sinatra, completely conventional doctor, doing pacemakers, heart transplants, drugs, the usual thing, and came to the view that not all heart disease is caused by poor blood supply. At least a half, and he reckons probably more, are due to a failure of mitochondria in the heart. Now, all heart cells are energized. In fact, all cells in the body are energized by mitochondria. And mitochondria are responsible for taking food in the form of sugars, proteins, and fats, and together with oxygen, converting that into energy that the cell can use. And Sinatra put together a package of supplements to support mitochondria, and he found he was able to reverse cases of heart failure, of heart disease, by this mitochondrial package of supplements. So that gave me the idea, and in fact he states it in his book, that maybe chronic fatigue syndrome is simply a symptom of a generalized mitochondrial failure. So the idea goes something like this. If you think of that whole piece of paper as a cell, cells are full of mitochondria. Indeed, each heart cell has anything between 2,000 and 3,000 mitochondria contained within it. The job of mitochondria is to produce ATP, requiring oxygen and fuel as a substrate. And what happens in mitochondrial failure is that recycling of ATP goes slow. Now, I'm only looking for 2 symptoms to make a diagnosis of chronic fatigue syndrome. The first symptom is very poor stamina. So my patients can do exactly what I do, but they can't sustain it and they have to go much slower. And this reflects slow recycling of ATP. So if a mitochondria is functioning normally, one molecule of ATP will release its energy, convert into ADP, pass back into mitochondria, and be reformed every 10 seconds. And what happens in chronic fatigue syndrome is that cycling goes slow, and that produces the first symptom of poor stamina. The second symptom I'm looking for in fatigue syndromes is delayed fatigue. So if they overdo things one day, they pay for it the next. And that happens when you stress the system. When you stress the system, you're asking for energy out of mitochondria faster than the mitochondrion can make it. And what that means is all the ATP that you've got gets converted into ADP, which is the diphosphate. So all your 3-phosphate gets converted into the diphosphate. If you ask for more energy, some of that ADP then gets converted into the monophosphate. Now, the trouble with AMP, adenosine monophosphate, is that can't be recycled. That leaks out of cells. And so as soon as you start to overdo things, you start to drain the energy molecules out of the cells. AMP gets lost as uric acid for the biochemists amongst you. So when that happens, this is what happens when my ME patients say, well, I went for a walk in the park, and I overdid things a little bit, and I had to lie down and mobile phone home in order to get somebody to come and pick me up, because they've literally drained all the energy molecules out of the system. With no ADP coming back into mitochondria, they then have to make brand new de novo ATP. This the body can do from glucose via the pentose phosphate shunt, but it's slow. It takes some days to happen. It produces an intermediate 5-carbon molecule called D-ribose. And that explains the delayed fatigue, because you're hanging around waiting for your pentose phosphate shunt to swing into action and make you some fresh ATP. In the interim, the cells can cheat. They can switch into a more primitive form of metabolism. They can switch into anaerobic metabolism, which is without glucose. It's very inefficient. It doesn't produce much ATP, but it produces an awful lot of lactic acid. And lactic acid is what gives you the muscle pain. Any athlete will tell you they've experienced this muscle pain. If I tried to sprint 400 yards, I would get a build-up of lactic acid in my muscles, and they would be very painful. I would then quickly switch back into mitochondrial metabolism, and the lactic acid would be cleared. This, of course, doesn't happen in people with fatigue syndromes because their mitochondria don't work. And the lactic acid actually damages muscles and causes muscle pain and tissue damage. So this is the model of what goes wrong in people with chronic fatigue syndrome, because mitochondria can be damaged in lots of different ways. For example, number one, mitochondria have their own DNA. It only has 18 genes. It's circular. It mixes freely in the mitochondria, and therefore it's very susceptible to damage as a result of free radical activity. And indeed, mitochondrial DNA determine the normal aging process. And if we damage our mitochondrial DNA, we accelerate the normal aging process. And that's why we see people with fatigue syndromes getting diseases before their time. That's why they are more prone to getting heart disease, to neurodegenerative conditions, to cancer. This is why the Gulf War veterans have so many different disease problems, because they have damaged their mitochondrial DNA. If the DNA is damaged, they don't have the genetic machinery to make the molecules necessary for oxidative phosphorylation to work. We will become fatigued if our ATP levels are low, as signaled by the figure 2 there, and we can correct that by giving our patients D-ribose. If they're magnesium deficient, they are unable to release energy from ATP. And magnesium deficiency, we know, is an extremely common problem in patients with fatigue. If they can't move ADP into mitochondria or get ATP out of mitochondria because of translocator protein blockages, then that cycle will go slow. And when you think that mitochondrial membranes are 80% made up of translocator protein, that can be a very big problem. The process of sticking a phosphate group onto ADP to create ADP is called oxidative phosphorylation. It's no wonder that organophosphates cause fatigue, because they directly inhibit this process of phosphorylation. In order for oxidative phosphorylation to take place, it needs certain key molecules, like coenzyme Q10, which is the main electron acceptor and donator in the process of oxidative phosphorylation. We have to be able to get acetate groups into mitochondria. That requires a carrier protein across the mitochondrial membrane called acetyl L-carnitine. And that, again, has been shown in trials to be an effective treatment in fatigue syndromes. Lack of oxygen, for example, will also cause a chronic fatigue syndrome. So thinking about, say, the aging process, what do my patients come and tell me? They say, I'm 20, but I feel like somebody who's 80 or 90 years old. As we age, we all get a chronic fatigue syndrome as our mitochondria fail. So that's the model of what goes wrong. And again, thanks to John McLaren Howard, we can measure all this. We can measure mitochondrial function by measuring the level of ATP in mitochondria, by measuring how efficiently energy is released from mitochondria, by looking at the rate of oxidative phosphorylation and how efficiently we can create ATP from ADP. And again, thanks to John, we can look at translocator protein function. We can see how efficiently ADP is moved into mitochondria and how efficiently ATP is moved out of mitochondria. The first I've done over 400 of these tests now, and Biolab, a medical unit, have done some thousands of these tests. And we can very easily score these tests from the level of ATP that's there, by how easily energy is released from ATP, by the rate of oxidative phosphorylation, and by how efficiently mitochondria move ADP and ATP around. All these results can be scored. So the first 71 patients that came to me completely at random, I scored them clinically as to how fatigued they were. I then sent their bloods down to John McLaren Howard, who did the test. He didn't know how fatigued they were. He just sent me the test results. And then we got what we call the mitochondrial function score as a result of scoring the various parameters measured on that test. And if we look at the mitochondrial function scores, i.e. how well the mitochondria work, and we graph that against the level of clinical disability, we get a very nice straight-line relationship. Now, what this means is that I can tell my patients how fatigued they are. They don't have to tell me how fatigued they are. I.e., we've got a good objective test of fatigue. We can identify where the biochemical lesion is, and we have got a package of supplements that we can put in place that corrects those biochemical lesions. Where we fall into trouble is with translocated protein, because translocated protein function isn't generally amenable to nutritional corrections. But again, thanks to John, he can look at mitochondria directly, and by using specific antibody fluorescent stains, he can identify what it is that's stuck onto mitochondrial membranes. And there are now literally hundreds of these specific antibody stains that can be used, which allows him to identify if there's viral or RNA stuck onto mitochondria, if there is lactic acid stuck onto mitochondrial translocated proteins, if there are organophosphates, if there are organochlorines, in fact, a whole range of different things which will tell us exactly why the translocated protein problem is there, if indeed there's a problem at all. So we can now look at chronic fatigue as a symptom of mitochondrial failure and look at the various ways in which mitochondria can be damaged and attack this in a logical way. For example, genetic causes. Mitochondria are inherited down the female line. You get your mitochondria from your mother, not from your father. And clinically, I see lots of mother-daughter or mother-son combinations with fatigue syndromes. It's unusual to see father-daughter, father-son combinations. Your longevity, for example, is determined down the female line. Mitochondria will, determine how well you can function as an athlete. And, for example, in the racehorse industry, a lot more store is put by the bloodlines down the female line for a stamina and an athletic performance rather than the male line. So you want a good mare, you don't want a good stallion. An obvious cause of mitochondrial failure will be not enough substrate. And, of course, we know people in respiratory failure, in heart failure, not enough oxygen getting there, they're going to fail. People with respiratory failure and heart failure present with chronic fatigue syndromes. It's a symptom of that failure. Starvation, who came out of Belsen without a chronic fatigue syndrome? They all did. Anybody who's going to be starved is going to have a chronic fatigue syndrome for very obvious reasons. A major cause of fatigue is fluctuating levels of blood sugar. And diet and hypoglycemia I now see as a major cause of fatigue because it impacts on mitochondria directly. And I'm just going to digress and talk about that in a little bit more detail because it's such a major cause of fatigue. I see sugar addiction and sugar intolerance and carbohydrate intolerance as a very major cause of fatigue. And sugar is very addictive. The reason it's addictive is because in the short term, the brain works better when the blood sugar levels are running high, and it has a calming effect. We all know our comfort foods. We know the foods we go for when we're stressed. But it has the effect of putting the blood sugar levels high. When the blood level sugars go high, this is potentially very damaging to muscles. And there is a little perivascular cuff of fat that samples blood sugar levels, and if they go too high, it shuts off the blood supply to muscles. So if you shut off the blood supply to muscles because the blood sugar is running a bit high, you shut off the oxygen supply. So you switch off your mitochondria when the blood sugar levels is running too high and cause fatigue. As the blood levels come back down again, they switch them on again, And then when you get hypoglycemia, if the blood sugar levels go low, then of course you simply haven't got enough sugar to supply the mitochondria, and you switch them off again. And so we go through people who are sugar addicts, carbohydrate addicts, they go through the day with fluctuating blood sugar levels, switching their mitochondria on and off and on and off. And clinically, this is an extremely common and major cause of fatigue. Back to the reasons again. Chronic lack of sleep, a major cause of fatigue. It's during sleep that essentially organs hit the body heals and repair. Every living organism, right down to bacteria, have to have times in their life, times in 24 hours of quiescence, when they are shut down and healing and repair takes place. Most of my patients with fatigue are chronically deprived of sleep for various reasons, for reasons of hypoglycemia, for reasons of allergy, for reasons of chronic pain, or whatever. And I say that's when mitochondria are healed. Poor micronutrient status. I mean, for the very complicated molecular machinery in mitochondria to function, they need certain key molecules. And these have been identified by the American cardiologist, so I didn't have to do that work. Coenzyme Q10, as I say, is the most important donator and acceptor of electrons in oxidative phosphorylation. Magnesium is an essential cofactor for many of the processes in oxidative phosphorylation. It is also essential for the release of energy from ATP. Without magnesium, you can't convert ATP into ADP. Acetyl-L-carnitine, again, important carrier molecule that carries acetate groups into mitochondria where they're then oxidized. Vitamin B3 is an important intermediary between Krebs citric acid cycle and oxidative phosphorylation. Lack of B3 alone will result in fatigue. Essential fatty acids are vital for cell membranes, and all this activity, all this metabolic activity takes place on the cell membranes. You don't have essential fatty acids, you can't hold the enzymes in the right place for these things to all work. D-ribose, again, I'm coming to the view that as we age, we get what I want to call acquired metabolic dyslexias. Our biochemistry becomes less efficient at making certain key molecules. Two of those undoubtedly are coenzyme Q10 and D-ribose. It's a difficult bit of biochemistry to make those molecules, but without those molecules, the mitochondria simply are not going to work. And I'm coming to the view that as we age, we should probably all be taking those supplements in order to slow that aging process. We can then damage mitochondria in lots of different ways. We can damage them by toxins that will damage either mitochondrial or genomic DNA. We can block translocator protein. We can block enzymes directly. For example, as I said, organophosphates inhibit oxidative phosphorylation. Heavy metals, nickel and mercury are the main two metals that John McLaren identifies sitting on translocator protein and blocking that function. Antioxidants, free radicals, are extremely good at causing damage. They cause a similar type of damage as exogenous toxins. We're all producing free radicals all the time. It's an inevitable part of normal metabolism. We can't live without producing free radicals. But we have a very good system for mopping up those free radicals, which are our antioxidants. And the frontline antioxidants are superoxide dismutase, which is the most important antioxidant inside cells, glutathione peroxidase, vital outside cells, and coenzyme Q10 as an electron acceptor is one of the most important antioxidants inside mitochondria. And so if our antioxidant system breaks down in any way, we're going to switch on our own OO cycle and magnify up all the other problems that were there previously. Unwanted immune activity, the way the immune system fights viruses, bacteria, whatever, is by producing free radicals. And so excessive unwanted immune activity will damage our mitochondria directly, and that can occur through allergies to foods, to chemicals, to microorganisms, chronic low-grade infections, yeast, mycoplasma, autoimmune effects. Again, its immune activity produces free radicals, switches on the OO cycle, and damages the molecular machinery of mitochondria. And then, of course, we have the mitochondria themselves, how they're controlled, whether they're under hormonal influence. I see lots of patients with borderline thyroid function, with maybe running low normal T4s, low normal T3s, and you give them thyroid supplements so they run high normal T4s and high normal T3s, and they feel an awful lot better. And an analogy I regularly use is if you think of your body as a car, the mitochondria are the engine of your car, the thyroid gland is the accelerator pedal of your car, And the adrenal gland is like the gearbox. It's all got to be working for that car to go. But when you fix it, it goes perfectly well, and it'll run for another 200,000 miles or whatever. This isn't the complete list of reasons for mitochondrial failure. I don't know all the reasons. There are going to be others, and we're learning about those all the time. What we have to do is we have to identify the underlying biochemical lesions, and we have to address as many of those as we possibly can, and that takes time. And the first and most important clinical goal that we have to achieve is I want that patient feeling absolutely fine, doing absolutely nothing. And the reason for that, if they're not feeling fine, it's because they're actually damaging their tissues as a result of all these things that are going wrong. And we can measure that damage to the tissues. This is work done by John McLaren Howard, who measures levels of cell-free DNA in the blood. Now, if you take a blood sample, any DNA in the blood should be wrapped up inside a cell. It should be packaged up. If DNA is swirling around in the bloodstream, not packaged up, then we call it obviously cell-free DNA. And it is a measure of cell damage. Now, normal people would have a cell-free DNA of somewhere by about 4.4 micrograms per litre, something like that. Normal range up to about 9.5. If I had somebody who was on cancer chemotherapy or who was suffering from acute influenza, they'd be running a cell-free DNA in maybe their 20s or the 30s. And what we see people with acute viral onset or non-viral onset, i.e. chemically induced, is we see these extremely high cell-free DNAs. And with time, as they learn to pace, they start to come down a little bit. These are very abnormal results. It tells me the patient is very ill. And the point about that is clinically, that manifests with the symptom of malaise. People say, I feel dreadful. I feel tired, but it's not tired, it's more than that. It's an ill tiredness. And of course, what the body is trying to do is get rid of all this cellular debris, all the cellular rubbish that's swilling around. And it does that by the immune system being activated. But the process of activating the immune system against this cellular debris switches it on. And you risk switching on allergies, and you risk switching on autoimmunity. So the business of feeling ill is a disease-amplifying process. And it emphasizes the importance of resting and pacing. If you don't rest and pace, you actually risk switching on more problems than you've already got, and you will certainly take a lot longer to get well. And it's a lot more difficult to correct all the underlying biochemical lesions if you're adding to them all the time by not pacing. So this emphasizes the importance of resting and pacing. Once my patients feel absolutely fine, doing absolutely nothing, then they can very, very gradually start a graded activity program. But that must be on the proviso that they continue to feel absolutely fine and they don't get delayed fatigue. If they get either of those things, they've got to drop back a level until they feel absolutely fine. So there is a place eventually for an activity program, but if you do that before you've addressed the underlying physical causes, you will make that patient an awful lot worse. And I'll finish on this note. I consider it medical negligence to take a psychological approach without first addressing and considering all the underlying physical causes. Thank you very much. To get the full package of mitochondrial tests, then Biolab in London do these tests, and it's about £170, I think, to get the whole package done. But if you phone Biolab, they will tell you. So it's very possible to do them. I mean, all my information about how I treat fatigue syndromes is all on my website. It's free. My book is there free for anybody to download if they want it. The actual regimes of supplements are all there. And I've tried to set it up in such a way that if you've got your GP on site who can help you with the B12 injections, if that's what you need, because they mop up peroxynitrite with the magnesium, with the coenzyme Q10. All these things are available on NHS prescription. The thyroid function tests are available on the NHS if you can persuade your GP to do them. So the idea of the website is so that people don't have to come and see me. They can do it themselves with their GP and put all these things in place. I mean, if they get stuck, I will do my best to help.